Okay, this is part 2 of lesson 2 on our prime number sieve. So first thing, always make sure you put on your heading, name, number, date, first and last in cursive. So Mrs. Gominiak. Now you don't have to put the date I'm putting, you put the date for which you're actually doing these notes. But for me, that's 8/14/18. So whatever date you're working on these notes, you put that date. My number is pi, and the subject is math. Okay, so we're going to be using our tool to kind of help check these answers here. So this tells me to list, I'm going to make a list, all factors. So I'm looking for all factors. Those are the numbers that multiply to make another number. For 9, tell if it's prime or composite. So does it have exactly 2 factors or more than 2 factors? So we're looking at 9. 2 factors we always know are 1 and the number itself. So 1 times 9, or commutative property, 9 times 1. Now, thinking of our divisibility rules, I'm going to think of the next number after 1, which is 2. Is 9 a multiple of 2? Well, it's not even, so 2 is not a factor. Then we try 3. Well, yes, 3 times 3 equals 9. That means it's actually a perfect square when both the factors are the same to make it. 9 is a perfect square. So is there any other counting numbers between 3 and 3? No. So we have found all the factors. 1, 3, and 9. We always list our factors from least to greatest. So the first step is to list all factors. So our list of factors, our list of factors is 1, 3, and 9. And now we see how many factors do we have? 1, 2, 3. 3 factors. Is that exactly 2 factors or more than 2 factors? More than 2 factors, so it is composite. Okay, next one. We're going to list. Remember, we put boxes around keywords. We're going to list all factors for 17, and we circle numbers, and tell if it's prime or composite. So we're looking at 17 now. 2 factors we always know, 1 and the number itself. Okay, and then 17 times 1. Let's see, now we're going to go through the divisibility rules. Is 2 a factor? Well, the rule for 2 is that it ends in an even number. 7 is odd, so 2 is not a factor. The rule for 3 is that you can add the digits together. 1 plus 7 equals 8. 8 is not a multiple of 3, so 3 is not a factor. Since 2 is not a factor, no even number will be. So I'm going to try the next odd number, which is 5. The rule for 5 is that it ends in a 0 or 5, and it does not. So 5 is not a factor. Okay, we try 7. 7, 14, 21. No, 17 is not in the list of 7, so 7 is not a factor. We try 9. 9 has the same rule as 3. When we add the digits together, we get 8. 8 is not a multiple of 9. We try 11. 11, 22. No, 11 is not a factor. 13 we try. 13, 26. No. We try 15. 15, 30. No. So there's no other factors. So we only have 1 and 17. So our list of factors is 1 and 17. How many factors is that? 2. Exactly 2 factors. Well, that's the definition for prime. So this is a prime number. Okay, next one. We're going to list all factors for 1 and tell if it's prime or composite. So 1. We know that the factors, it's 1 times the number itself, 1 times 1. There's no counting numbers between 1 and 1, so that's it. That's our factor. So if we list our factors, is 1. Now, is that exactly 2 factors or more than 2 factors? We only have 1 factor, so that doesn't meet either definition. It's not exactly 2 and it's not more than 2. So this one's neither one. It's the only counting number that is neither prime nor composite. That tricks people sometimes. They think it's prime. All right, here we're going to do list all factors for 51. Tell if it's prime or composite. 51. Well, 2 factors we always know are 1 and the number itself. Using the commutative property of multiplication, I can also write 51 times 1. Going through my divisibility rules, next I try 2. The rule for 2 is that it ends in an even number. It ends in an odd number, so 2 is not a factor. And no other even number will be a factor. So we try 3. 5 plus 1 equals 6. So 6 is a multiple of 3, so 3 is a factor. 3 times something. So if we look on the multiplication chart, we can see that 3 times 17, it makes 51. Okay, we try 5. The rule for 5 is it ends in a 0 or 5. It doesn't end in a 0 or 5, so 5 is not a factor. We try 7. Well, I know that 7 times 7 is 49, and then 56. So 51's not in that list, so 7's not a factor. We try 9. It has the same rule as 3. As you add the digits together, we get 6. 6 is not a multiple of 9, so 9's not a factor. We try 11. Well, 11 times 4 is 44. 11 times 5 is 55, so that's not in the list. We try 13. 13 times 5 is 65, so that's too big. Let's see. If I list my 13s, 13, 26, 39, 52. Nope, that's not in for the 13s. We try 15. 15, 30, 45, 60. Oh, that's already way past there. And then we get to 17, because we only have to check the factors between these two. So we're done. Let's list them from least to greatest. 1, 3, 17, 51. So list of factors. Because we're making a list, we use what's called a colon at the end here. That's those 2 dots. It's called a colon. And we use that for lists. So we have 1, 3, 17, 51. How many total factors we have? We have 4 factors. Is that exactly 2 factors or more than 2 factors? Well, 4 is more than 2 factors, so it is composite. And now we can check with our prime number sieve if we got these correct. So we're checking for 9, 17, 1, and 51. So 9 we said was composite, and it is crossed out. It is composite. 17 we said was prime, and yes, it's circled as prime. 1 is neither. It's crossed out. And then 51 we said is composite, and it is crossed out. So we got them all correct. All right, go ahead and close up your notebook, and thank you for joining me.